Good day everyone. This is Engineer Armando Omanito, and our topic for today is mixture problem under the subject Algebra. So let's have the problem. A smelting company receives an order for at least 12 T of lead, 10 T of copper, and 14 T of iron. So by the way, I just copied this problem in its original form, and I was tempted to to make this stance, but I decided finally to make it just the same letter T. So uh, okay, so I will repeat the problem. A smelting company receives an order for at least 12 T of lead, 10 T of copper, and 14 T of iron. The order can be filled by melting down either of two ores, X or Y. Each railroad car of X ore contains 2 T of lead, 1 T of copper, and 1 T of iron. Each railroad car of Y ore contains 1 T of lead, 1 T of copper, and 2 T of iron. If it costs $4,000 to buy and process each carload of ore X and $5,000 to buy and process each carload of ore Y, how many carloads of each should be purchased to fill the order at minimum cost? What is the minimum cost? Okay. So in short, in this problem, you are a supplier of lead, copper, and iron, and you have a client, and you are required to supply your client his order of 12 T of lead, 10 T of copper, and 14 T of iron with the following production costs. So if you will purchase uh, or X uh, from the original, meaning from the main source, so the production cost is $4,000. So if you will purchase or X, and if you will purchase or Y, the production cost per carload is $5,000. So you don't know the number of carloads that you must purchase or buy in or X or for or X, and the number of carloads that you must purchase for or Y. Okay. So, uh, okay, we have already tabulated the given items or the given values here. Okay, using tabulated solution. So now, uh, using the table of lead and copper for ore X and Y, so this is table 1. So first, let us use the values for lead and copper. So, uh, we have to multiply, so 2T multiplied by A, or the number of carloads that you must purchase for the lead, and then 1T multiplied by B for the number of carloads for the copper. So the same with or Y. So this is for or X, this one. And for or Y, we have 1T multiplied by A and 1T multiplied by B to get the required 12T, and the same with or X required 12T. So, multiplying that, we will get 2A plus B is equal to 12, and 1 plus B is equal to 10. So, this is two equations with two unknowns, and using mode 5.1 of our calculator, we will get A to be 2 carloads and B to be 8 carloads. Okay, so let us tabulate the what we have solved. Okay, so if you will, so the result is 2 carloads of X and 8 carloads of Y for the table of lead and copper in our previous table here. So if we are going to purchase 2 carloads of or X and 8 carloads of or Y, so So for every carload, we have 2T of lead. So multiplied by 2 carloads is 40. And then the same with copper, 1T times 2 carloads is we can get 2T, and iron 1T or 1 tons multiplied by 2, we will get 2 tons. And for the production cost, so 2 carloads multiplied by $4,000 per carload is $8,000. Okay, and for or Y, a total of 8 carloads multiplied by $5,000 per carload is equal to $40,000. So, the result now is you can get 12 tons of lead in the combination of 2 and 8 carloads of X and Y, and 10 tons of copper and 18 tons of iron. So the total production cost is $48,000. So this is a valid a valid values in our in here in our uh, table, because the client needs 12T of lead, 10T of copper, and 14T of iron. And we can get from the combination of 2 and 8 carloads 12T of lead, 10T of copper, and 18T or 18 tons of iron. 18 tons is greater than the 14 tons required. So this is acceptable. Now, using the table of copper and iron, so before we use the table for lead and copper. Now we will use the table for copper and iron here. Okay. So, using that, so in copper, we have in RX, we have 1T of copper. So multiplied by A, and then 1T of iron multiplied by B here. Copper and iron, A. And then, so, next is multiplied 1T multiplied by A, and then 2T multiplied by B here. So, that is or X. So this is for or Y. This is for or X, and this is for or Y. So using again mode 5.1, we will get for A or for X, we will be able to we must purchase 6 carloads of or X here, and 4 carloads of or Y here. So again, if we will tabulate that, so in every 6 carloads of X, so for every carloads, there are 2 tons of lead, so multiplied by 6 carloads is 12 tons. And then same with the copper and iron, so we will get this production cost, $24,000. And for RY, we will get a total production cost of $20,000. So, for the combination of 6 carloads of or X and or Y, we can get 16 tons of lead, 10 tons of copper, and 14 tons of iron. So this again is acceptable since the required lead of our client is only 12 tons, but so we have 16 tons. And then we have the required copper by our client is 10 tons, we have 10 tons. And for the iron, we have, the required amount by our client is 14 tons, and we have 14 tons. So the total production cost is $44,000. And using the table, our table for lead and iron, so the third one is for lead and iron. So 2T multiplied by A, or the number of carloads to be purchased, and then 1T multiplied by B. So this is for or X. And then the same with this for or Y. So, using mode 5.1 of our calculator, we will get A to be 10/3 and B 16/3. This is an invalid value since we can only purchase per carload. So we cannot purchase a carload at a carload in fractions. Okay, wait. So here, this is invalid since a carload should always be a whole number. So let's have other options. So we have already the table. If we will purchase 2 carloads of X and 8 carloads of Y, and then 6 carloads of X and 4 carloads of Y. So other options are here. So what if we purchase 4 carloads of X and 6 carloads of Y? So, by the way, so how did we able to get 4 carloads of X and 6 carloads for or Y? So how did we able to estimate? So because our client requires us to supply, for example, the copper. The client requires 10 tons. So if in or X it has a 1 ton. So in 4 carloads it has 4 tons. And in or Y it has 1 tons of copper. So multiplied by 6 is equal to 6 tons. So 4 plus T tons is equal to 10 tons. So this is acceptable. So let us continue with this solution. So 4 carloads multiplied by 2T of lead is equal to 8T, and then 6 carloads for or Y multiplied by 1 tons is equal to 14 tons. So this is acceptable since our client only needs 12 tons. So this is already acceptable, and then this is also acceptable since this is greater than the 14 tons required by our client. And the total production cost is $46,000. Now, another option is if we will purchase 8 carloads of X and 3 carloads of Y. So, this again for the copper. So, because in or X, it only has 1 tons of copper. So, multiplied by 8 is 8 tons. And then for or Y, it only have 1 tons of copper multiplied by 3, we will get 3 tons. So, a total of 11 tons. Again, this is greater than the 10 tons required by our client for the copper. So, using these values, we will get a total of 19 tons for lead and 14 tons of iron. So again, this is acceptable since our client only needs 12 tons of lead, 10 tons of copper, and 14 tons of iron. Okay. So, and the total production cost is $47,000. Now, let us summarize our solution. So, for our first in our one option, 2 carloads of X and 8 carloads of Y. So, here, for our first option, 2 carloads of X and 8 carloads of Y. So, and then our next option is 4 carloads of or X and 6 carloads of or Y. And then our third option is 6 carloads of or X and 4 carloads of or Y. Here. And then the last option is 8 carloads of X and 3 carloads of or Y. So, if we are also tabulate the production cost, we will get the most advisable or the minimum production cost is by purchasing 6 carloads of or X and 4 carloads of or Y, which will only cost $44,000. So, here, for the best option, the company must purchase 6 carloads of or X and 4 carloads of or Y. So, and the minimum production cost is $44,000. So, again, this is Engineer Armando Omanito. Until next time, and may God bless us all.